So today we're going to finish up chapter 5, section 2. Yesterday we started it. Yesterday we talked about the 6 trig functions. Remember in geometry you learned them as SOHCAHTOA, but here you're going to memorize them as sine is equal to y over r. Its reciprocal is cosecant, r over y. Then cosine is x over r. Reciprocal is secant, r over x. Tangent y over x, and cotangent x over y. So remember the little hint I gave you about sine? If you think about it towards your faith, why should you sin? The y goes with sine, and then just know that the cosine gets the x. Then we also did an example. These were the first 4 questions of your homework last night. That is due tomorrow. And then we talked about the angles that are formed on the axis. So for example, the 90, 180, 270, or 360, and you're going to use the 4 order pairs that you would encounter, the first integer ones. So 0, 1 for the 90, -1, 0 for the 180, and then for the 270, 0, -1, and then for the 360 or the -360, 1 and 0. Same thing up here. This would be -270. Over here would be -180, and then down here would have been -90. Now you may also have to go around multiple times. Let's say it was a 720 degree angle. Know that it would still end up and use order pair 1, 0. So then we did filled in all these examples. Then these are the reciprocal identities. We're going to be using these when we're trying to solve for different trig functions. But we've already seen these when we did that first slide. Know that the reciprocal of sine is cosecant, reciprocal of cosine is secant, and reciprocal of tangent is cotangent. Then we applied those. Remember, if they're asking, they're not going to tell you to use a reciprocal identity. They're just going to say, find the value of a different trig function. So these two are reciprocals. So all we had to do was flip the fraction. Then here, same thing, these are reciprocals. The only challenging thing here was we had to rationalize this. And then once we rationalized it, we got the final answer of, we would square root it, and this is negative, and then -2 square root 6 over 6, and then simplify it, divide them both by 2, and then it was negative square root 6 over 3. Then we saw the different solution intervals. So remember, sine and cosine are always going to be basically fractions. They're going to be numbers in between -1 and +1. The reciprocal to sine and cosine, those are going to be the secant and the cosecant. So these are here, and they're going to be numbers that are greater than 1, greater than or equal to 1, or less than or equal to 1, -1. And then tangent can be all real numbers. It could be anything. Sometimes it'll end up being an improper fraction, sometimes just a regular fraction. It could also be an integer. We also saw the Pythagorean identities, and I told you yesterday to be able to manipulate these Pythagorean identities and solve for any part of it. Because the next slide, this is where we left off, doing an example, applying the Pythagorean identities. You're also going to see the quotient identities coming up as well. So we left off here. We did the first example. We did example 5. Okay, so for number 6, they're giving us cotangent, and they want us to find cosecant. So they're also telling us that this angle measure is in quadrant 4. So if you do your all students take calculus, quadrant 4 is over here. And we know the only thing that's going to be positive in quadrant 4 is going to be cosine and its reciprocal. Those are going to be the positive ones. So when we go to get our answer of cosecant, know that this is going to be a negative number. Because in quadrant 4, sine, cosecant, tangent, and cotangent, these 4 are all negative. So, and you can also see here that cotangent is negative. So now I need to figure out which trig which Pythagorean identity I'm going to use. So the one that has cotangent in it is going to be the identity that is 1 plus cotangent squared x is equal to cosecant squared x. And what's nice about this is as soon as I plug in cotangent and I square it and then I square root it, I'm going to get my answer. I'm not going to have to use an additional identity like we had to do on number 5. So I'm going to replace cotangent squared with this 1/2, negative 1/2, but I have to square it because the formula has cotangent squared. And then I'm going to rewrite everything else.
What about the x?
Now, I'm going to go ahead and square it. And I get 1/4 because 1/2 times 1/2, 1 times 1 is 1, 2 times 2 is 4, and negative times negative is a positive. Now what I need to do is add these two. So I'm going to go ahead and change my whole number 1 into a 4 over 4, so it has a common denominator. It's going to be easier because I have to square root this. So if I do it as a decimal, I'm not going to be able to get the correct answer. So I'm going to add. And I don't want cosecant squared. I want just cosecant. So I have to square root both sides. Square rooting the square cancels it. So now I'm left with positive and negative the square root of 5 over 2. Because what I can do here is square root each of these individually. And that gives me cosecant of x. Now, I need to decide which one I need to keep. And remember up at the top, remember when I did my all students take calculus, remember I told you that cosecant up here needs to be negative. So I'm only going to keep the negative answer because cosecant is negative in quadrant 4. So my answer to this problem is going to be negative square root 5 over 2 because cosecant, and I can put theta. The x that's there in the identity on that formula sheet is just holding the place of the angle. Theta is just a variable, and you could have also, because that's what we did here, cosecant x and cosecant theta, these are the same things. These are just variables. So the answer is negative square root 5 over 2. In the given, it said that it was in quadrant 4. So in quadrant 4, the only thing that's going to be positive is cosine and its reciprocal. So because I was looking for cosecant, I know cosecant in the 4th quadrant is negative. So that's how I know to keep only the negative. Quiz on Monday. If all you tell me on the line is the answer is this, with none of this work to back it up, you get it wrong. Even if you have the right answer on the line, you have to have all the work to back it up. Example 7. So it wants us to find the value of the 6 trig functions of the angle in standard position running through the order pair -4, 0. Soon as you see that in your order pair, you've got a 0 in either the x or the y spot, this should be a clue that it's one of those axis angles, a 90, a 180, or a 270. So if I go to graph this order pair, -4, 0 is located right here. So this is going to be a 180-degree angle. So this is where we're going to go ahead and we have our x value, -4. We have our y value. We need to find our r value. Now, a little hint or a little shortcut, whenever the angle is on one of the axes, so this is a 180-degree angle that we're forming, you can use the first order pair here. You can use the -1, 0, because it doesn't really matter as long as it's on that axis. So if you wanted to do that, then remember, anytime you use that first order pair, your r value is 1. So then this will simplify things and you're not going to have to simplify the fractions. However, you can still do r equals x squared plus y squared and square root it. So we would, if we use the original order pair, negative 4 squared plus 0 squared under the square root, and I would get 16 plus 0, and r equals 4. Now, I'm going to show you that it doesn't matter if I use my original given and use the negative 4, 0, negative 4 for x, 0 for y, and 4 for r. I'm going to show you you're going to get the same answer as if you would have done it with the negative 1 and the r equals negative 1. So if you use the r equals 1, you have to use that first order pair that you're hitting. But let me show you, you can still use the given. So remember, we're going to plug them into the 6 trig functions that you're memorizing from that very first slide. So what we're going to do here is the sign, and we're doing 180 because that's where that order pair is located. And remember, sine is y over r. Why should you sin? So then we're going to put the y value in, 0 over 4. I'm using the original given. And then remember, whenever 0 is in the numerator, it simplifies to 0. Remember, the reciprocal to sine is cosecant. So if I flip it, r over y, and I put in 4 over 0, whenever there's a 0 in the denominator, it's undefined, so no solution. Using the given, so cosine of 180 is x over r, and my x value is negative 4, and then over 4, and then we would get negative 1, and then its reciprocal is secant, and we would do the flip, so r over x, so 4 over negative 4, and it's also negative 1. And then if you do tangent, y over x, my y value is 0, my x value is negative 4, 0 in the numerator simplifies to a 0. And then cotangent, the reciprocal, flip that x and that y, and then negative 4 over 0, and it's undefined. Yeah, thank you. All right, it needed to be 180. So this should have been 180. Theta is just a variable representing the angle, but we knew the angle because we had the order pair. So these should all be 180s. All right, so now let's say we didn't want to use that. We knew that when it ends up on either the x or the y axis, and it's like a 90 or 180 or 270, I don't necessarily have to use the order pair that's given. I can use that first one that you come to along the axis. So I could have also done this problem using the order pair negative 1, comma 0. So my x would have been negative 1, my y is 0. And remember, whenever you use that first order pair, the r value is always 1. So if you plug it in, sine of 180, remember it's y over r, so 0 over 1, and it's 0. Notice it's the same answer I got right here when I used a 4 for my r value. Then if I do its reciprocal, cosecant 180, flip it, r over y, and then this simplifies to 1 over 0, 0 in the denominator, undefined. Then cosine of 180, x over r, and your x is negative 1, your r is 1, and it's negative 1. Notice it was the same answer. I just had to simplify it and make it equal a negative 1. And then if you do secant of 180, flip it, r over x, 1 over negative 1, same answer, negative 1. And then tangent 180, y over x, 0 over negative 1, simplifies to 0, same answer I got here. And then cotangent of 180, flip it, x over y, and I get negative 1 over 0, undefined. Same answer using the original given. So if the ordered pair creates one of these quadrant angles that are on the x or the y axis, you don't necessarily have to use that ordered pair. You can use that first one that you would hit on that axis. Because it doesn't matter if I create my angle and I make it go from my initial side here and come over here to the negative 4, it's still a 180-degree angle no matter which order pair I stop on. It's still 180. So it doesn't matter which order pair over here that you use. Last two examples, you're going to need to figure out the value of these quadrant angles in order to answer these questions. You're going to have to substitute in that value. So let's go ahead and take a look. Now, we just did all the 180s, but I can go ahead and do it again for you. So what we need to do here is we need to figure out what secant of 180 is and what tangent of 360 is. So if I go ahead and have my axis here, 0, 90, 180, 270, and then 360 is here. So for the 180, remember you're using the ordered pair negative 1, 0. So for secant of 180, remember this is the reciprocal to cosine. So what I need to be doing here is r over x. And remember your r value is always 1 when you use these initial first order pairs. So 1 over negative 1. So secant of 180 is negative 1. So I'm going to come here and I'm going to do 3 times negative 1. Now I have to do tangent of 360. Well, 360 for my tangent, this is going to be this order pair, the 1, 0, because there's my 360. And remember, tangent is using y over x. So my y value is 0. My x value is 1. This simplifies to 0. So in here, I'm going to put tangent of 360 is 0. So now I'm going to multiply the 3 and the negative 1, multiply the 5 and the 0, and my final answer here is negative 3. I'm going to do the same thing for the bottom. So again, I already found the tangent of 360. I found that this is 0. I'm going to go back and I'm going to do the sine of 180. So I'm going to be doing 4 times the sine of 180. So if I come back over here, here's my 180 order pair again. Remember, sine uses, why should you sin? Y over r. So my y value is 0. My r value is 1. So the sine of 180 is 0. So put in a 0 here. And then the next one, I need to find cosine squared of 180. So I need to first find cosine of 180, and then I'm going to square that answer. So here's my 180 again. So cosine 180, remember that uses x over r. So it's negative 1 over 1. So cosine of 180 is negative 1. So here I'm going to be doing 2 times negative 1 squared, and negative 1 squared is positive 1. And then over here, 4 times 0 is 0, and then I had the 0 there. So my final answer here is just the 2 times 1, which is 2. I'm going to add a blank slide here. Okay, so you're going to get a question where they're going to say, given or find the quadrant where given that sine of theta is greater than 0 and cosine of theta is greater than 0. So we want to know which quadrant theta is located. So here's how we're going to do it. So when you have something that says greater than 0, this is telling me that sine of theta is going to be positive. Cosine of theta is also going to be positive because it's greater than 0. So here's where my all students take calculus comes into play. So I'm going to go ahead and I'm going to put a check mark in each quadrant where sine is positive. So remember, just to review, in quadrant number 1, all 6 are positive. In quadrant number 2, only sine and its reciprocal are the positive ones. And then down here in quadrant number 3, the T stands for tangent, because remember this was take, and it's reciprocal. And then the last one, and this S is standing for students. Let me go ahead and tell you what the letters stand for. Students. And then this A was all. And then the last one is the word calculus. And this stands for cosine and its reciprocal. And this is quadrant 4. So now I'm going to put check marks where I can see that sine is a positive answer. So sine is positive in quadrant 1 and in quadrant 2. Now I'm going to put check marks where cosine is positive. And it's positive here and here. So the answer where theta is going to be located is where you see both check marks. So it's going to be located in quadrant 1. So you're going to just have to put check marks where it's going to be positive, and then where you see both check marks, that's your answer. Now, if they gave you something and they said where sine of theta is negative, less than 0, then you would put check marks there. So you just have to look at the inequality symbol to see if they're referring to a positive or a negative answer. These are going to be like numbers 59 in the homework.